ihasmath, and you're going to learn how to draw special cases of line graphs. In the last video I showed you three methods to draw graphs from the gradient intercept form y is equal to mx plus c. In this video I will focus on some special cases, on vertical and horizontal lines, and on equations that are given in a different form. Let's start with horizontal lines. You have actually seen these before, but some students always get confused because the equation doesn't look like the usual y is equal to mx plus c. They are a special case because the gradient is 0 and no one bothers to write 0x, so it's simply no x in the equation. You can always interpret equations as rules that connect an x and a y value. In this case, it doesn't matter what the x value is, the y value is always going to be the same number. In order to draw a line graph of, say, y is equal to 7, simply do what you always do. Find the y-intercept, that's 7. The gradient is 0 because there is no x in the equation, so we just draw a horizontal line parallel to the x-axis. Notice that all points on the line have a y-coordinate of 7. They all follow the rule y is equal to 7. The second special case are vertical lines. They don't have a normal gradient either. If you try to draw a triangle to work out rise over run, you notice that the run is 0. You can't divide by 0, so the gradient is said to be not defined. Vertical lines don't have a y in the equation, so they definitely look different. In order to draw a graph of such a line, say x is equal to 9, just find a point that has an x-coordinate of 9, for example 9, 0, which is on the x-axis. Then draw a vertical line parallel to the y-axis. Notice that all the points on this line have an x-coordinate of 9. That's what the rule x is equal to 9 means. The last special case I want to tell you about is an equation that is also not written in the form y is equal to mx plus c. You can always do the algebra to change such an equation into the gradient intercept form, but you may get fractions for the y-intercept and the gradient, and this can make it harder to draw the line the normal way. There is a quicker method for drawing such equations. I call it the cover-up method. It's based on working out where the line will cross both axes. Let's try it. First, let's see where the line crosses the y-axis. At this point, x is equal to 0, and we just cover up the expression with the x because 6 times 0 is equal to 0. Forget about it. We're left with 10y is equal to 30. Divide both sides by 10 and you get y is equal to 3. So the y-intercept is 3. I repeat the process for the x-intercept. So y is equal to 0. Cover that up. 6x is equal to 30. Divide by 6. X is equal to 5 and bob to your uncle. Finally, we connect the points and we're done. These special cases are not hard. They're just different, and as always, they require some practice. Ideally, you mix them in with your regular diet of y is equal to mx plus c star questions.